Welcome to chemistry. This is going to be Unit 1, which is entitled Matter and Measurement. So since this is chemistry class, the first question is, what's chemistry? And the answer to that is, chemistry is the study of matter. So in this course, we'll be studying matter. The next question then seems to be, well, what's matter? And matter is defined as anything that has mass and takes up space. So there are a lot of things that have mass and take up space, so chemistry will be studying a heck of a lot of things. When you do chemistry, you are going to be doing a fair amount of lab work, because good science is based on experimentation. So you will be making observations, and we're used to thinking of observations as things you see, but really observations are information you obtain through any of your five senses. So not just what you see, but also what you smell, what you hear, etc. Observations, there are two types. Qualitative, which, like the name says, describes the quality of something, and quantitative, which, like the name says, describes the quantity of something. So we're looking at amounts, which means we will be looking at numbers. So if you're in the classroom, you look around and you say, okay, the walls are white. That would be a qualitative observation. Or the desks are hard. That would be a qualitative observation. If you look around and say there are 15 students in the class, that then would be a quantitative observation because you're talking about an amount, you have a number. Observations are different than inferences. Observations are the things you are actually seeing, whereas inferences are the explanations you make based on your observations. So the example we did in class was a cake with 3 candles. What you observe is a cake, qualitative observation. It has 3 candles. That's a quantitative observation. That's what you actually see. Your inference then, what you assume is it's a birthday cake for a 3-year-old. That's based on your observation of a cake with 3 candles. There are other inferences that could also be perfectly legitimate. You see a cake with 3 candles, that could also mean it's somebody's 3rd anniversary. It could mean that it's a birthday cake for a 30-year-old and they didn't want to put that many candles on the cake. So you need to be very clear when you're back in the lab that you are writing down what you observe and saving the explanations for later. When you're back in lab, you will be doing both qualitative and quantitative observations. You'll be looking at things like, is there a color change? Is a gas produced? Those will be qualitative observations. You will also be making a lot of measurements, quantitative observations, and so we need to talk about that a little bit. There are 4 basic quantities that we measure. First is length, which is defined as the distance between 2 points in a straight line. This is not one we'll be measuring very often. It doesn't come up in chemistry very much, but that is one quantity of measurement. Second is volume, which is the amount of space an object occupies. So in this room, the desk takes up a certain amount of space in the room, so that would be the volume of the desk. Third is mass, which is the amount of matter in an object. The desk is made up of wood and metal, so there's matter in the desk, and the amount of matter would be the mass of the desk. Just as kind of a technical distinction, mass is not really the same thing as weight. When you get on your bathroom scale at home, you are measuring your weight, which is different than your mass. Mass is the amount of matter. Weight is the amount of matter, but also includes the force of gravity. So when you're on your bathroom scale at home getting your weight, you're measuring how much matter's in you, but also the pull of gravity on that matter. So technical distinction, but in science class we'll be measuring mass. And the last quantity, temperature. We'll get into a technical definition for temperature later on in the semester, but for right now we're just going to stick with how hot or how cold something is. Now, we're Americans, so we're used to making these measurements in the English system. When we measure length, we measure feet or inches or miles. When we measure volume, we measure cups and pints and ounces. We measure temperature in degrees Fahrenheit. The rest of the world and the science community uses the metric system, which is also known as the SI system. And as a scientist, you must use the metric system. I will not take English measurements. We have to do the metric system. This system was developed by a guy named Antoine Lavoisier. He's a French chemist who, during the time of the French Revolution, got assigned the task of developing a new measurement system. And so Antoine Lavoisier got this job and said, okay, I can do that. He said, the first thing that I need to do is develop a unit of length. And he defined that, and so our unit of length in the metric system is the meter, abbreviated small m. He also then said, okay, need a unit of mass. We're going to measure that in grams, abbreviation small g. Volume we'll measure in liters, abbreviation capital L. And temperature we'll measure in Celsius, degrees Celsius. So again, in science class, you must use the metric system in all your measurements. You will also see this referred to as the SI system. Because Lavoisier was French, he called it Le Système International, the international system, and we know it also as the SI system. So these are the base units for measuring length, mass, volume, and temperature. They're not appropriate for everything. So if you want to measure the distance from Asheville to Los Angeles, you're not going to measure that in meters. You get too big a number. So we're going to use prefixes to get these base units to other units that make sense. So our metric prefixes, getting smaller than the base unit. If you take the meter and divide it into 10 equal pieces, you now have 1/10 of a meter, which is a decimeter. So deci means 1/10, abbreviation small d. Centi means 1/100th, abbreviation small c. So if you take the meter, divide it into 100 equal pieces, you would have a centimeter. And then milli means 1/1000th. 1/1000th of a meter would be a millimeter. So that's taking your base unit and getting smaller. You also need to be able to go bigger than the base unit. So deca is 10 times the base unit. So a decagram is 10 grams. We've already used D for deci, so we have to come up with another prefix for deca, which is DA. You may have learned this as a big D as well, but DA is the more accepted convention. So deca is 10 times larger. Hecto is 100 times larger, abbreviation small h. So a hectogram is 100 grams. And then same kind of thing, kilo is 1,000. So a kilogram is 1,000 grams. So you need to know these prefixes and what they mean. So let's do some examples. km. If you see that, that stands for kilo and meter. So you have a kilometer or kilometer. Kilo means 1,000, so 1 kilometer is 1,000 meters. mg, milligram. So that represents 1/1000th of a gram. dl, D is deci, L is liter, so this is a deciliter, which is 1/10 of a liter. That's different than DAL. DA is deca, so 1 deciliter is equivalent to 10 liters. So you need to know your metric prefixes and what they mean. Let's look at ways to measure volume. Okay, remember volume is the amount of space that an object occupies. So we've got 3 different ways that we're going to talk about as methods to measure the volume of something. First one, length times width times height. This is the formula for calculating the volume of a box. And the fancy words for box, a box is a rectangular solid. So anytime you have a box, something that's a rectangular solid, you can use this formula. Your units will end up being cubed because you'll have your length times your width times your height. So if you're measuring in centimeters, that would be centimeters times centimeters times centimeters, which gives you centimeters cubed. So length times width times height will give you cubic units. Graduated cylinder is what we're going to use for measuring the volume of liquids. You'll pour the liquid into the graduated cylinder. You'll read the bottom of the meniscus. The liquid will kind of dip, and you'll read the bottom of the dip. And when you measure that, it will be measured in milliliters. Our graduated cylinders measure in milliliters. Now, if you want to find the volume of something like a spoon or a pen or a pair of scissors, things that don't have a regular shape to them, you're going to do that using volume by water displacement. And we're going to do that for things that we call irregular solids, things that don't have a regular geometric pattern to them. And we're going to use the graduated cylinder to do this, so again the unit will be milliliter. The way this is going to work, the way water displacement works, you're going to put water into a graduated cylinder and you're going to record the volume of water that you have in there. You're going to carefully add the object into the graduated cylinder. And you're going to do this carefully because you don't want the water to splash out and you don't want to break the bottom of the graduated cylinder. So you're going to carefully add the object. And what's going to happen? What's going to happen is the water level goes up. So you're going to record the new volume. Now that the water level's gone up, that's going to be the volume of the water and the object together. So if I have the volume of the water and the object, and I initially recorded the volume of the water, then I can subtract to get the volume of the object by itself. So that's volume by water displacement. Last thing for